22.4 liters. So any gas at standard condition of temperature and pressure has the volume of 22.4 liters. Now, we are going now to answer the question. But we refer to our equation. We see that 1 mole of aluminium carbide produced 3 moles of methane. Okay? 1 mole of aluminium carbide produced 3 moles of methane gas. We know the number of mole of aluminium carbide here. What was the number of mole of aluminium carbide that we calculated that was necessary to produce 3.6 multiplied by 10 to the power 23 atoms of hydrogen? Do you remember? What was that? It was 0.05. 0.05. But because we see the ratio here between aluminium carbide and methane gas is of 1 aluminium carbide, you can see it there, for 3 moles of methane gas. We can see it there. Okay? Because we can see it, that means if we have 1 mole of aluminium carbide, this will produce 3 moles of methane. Then if we have 0.05 mole here, this will produce 3 multiplied by 0.05 mole. Okay? If we multiply, what you are going to have? We're going to have 0.15 mole. 0.15 mole. So we're going to write it there because you can not see it here properly. Okay, we're going to write it there. So this will produce 0.15 mole. 0.15 mole. 0.15 mole of methane gas. Now, but the question, our question is what volume? Because we know the number of mole, we know also that 1 mole of any gas in standard condition of temperature and pressure occupies a volume of 22.4 liters. We are going to do the calculation here. Now, I go to pipe here, but note that the number of mole that we got is 0.15. So now, 1 mole will occupy 22.4 liters. 0.15 mole will occupy 22.4 liters multiplied by 0.15. If we do so, we're going to get 3.36 liters. So this is the answer that we got. The volume, because the question was to get the volume of methane. So what volume of methane measured at STP was produced in the reaction? this volume of 3.36 liter is the volume that was produced in the reaction. Now, we are going to move to the very last part of the question. The very last part of the question, they say, find the volume of water used up in the reaction. Find the volume of water. Find the volume of water used up in the reaction. So, find the volume of water they give the density 1 used up in the reaction. Now, to answer the question here, we are going to refer again to our equation. The reference is our equation. Aluminium carbide, 1 mole of aluminium carbide, react with 12 moles of water. Okay, we can see there. Okay, we can see that 1 mole of aluminium carbide, 1 mole of aluminium carbide, react with 12 moles of water. Now, because we always refer to our equation, we see the ratio is 1 to 12. When we have 1 mole of aluminium carbide, this will react with 12 moles of water. Now, if we have 0.05 mole, this will react with how many moles of water? So we do 0.05 multiplied by 12 divided by 1 that we have there. So this will give what? If we do so, this will give, so we got 0.6. So 0.05 multiplied by 12, this will give 0.6 mole. 0.6 mole of 0.6 mole of water. 0.6 moles of water. Okay, so 0.05 moles of aluminium carbide going to react with 0.6 moles of water. But we need to get now the corresponding mass of water, and then we get also the volume. So we know that a number of mole is equal to mass divided by molar mass. number of mole is equal to mass divided by molar mass. Now, number of mole, we have it 0.6. Mass, molar mass, what is the molar mass of water? Is 18. 18 is the molar mass of water. So I put 18 here. Okay. Then cross multiplication, 0.6 multiplied by 18 will give the mass. So mass is equal to 0.6 multiplied by 18, and this will give what? This will give 10.8 grams. Okay, so we got the mass. We have the mass. Now, you may ask me, but what about that density? Yes, the density, we have been given the density because we are going to use this density to get the volume, the corresponding volume. But we see that 1 gram of water, the volume of 1 gram of water is 1 centimeter cubed. If 1 gram of water has the volume of 1 centimeter cubed, that means the volume of water will also be of 10.8 centimeter cubed. And finished. Okay, we finish here, and I'm so happy to continue the next class with you. Thank you.